Energy codes play a vital role in many areas that are important to our local economies, the well-being of our communities, and the conservation of valuable resources. Buildings utilize 40% of energy in the United States, and in Georgia, the majority of sources for our energy come from outside the state. Energy codes are designed to help us save energy and keep those savings in our local economies. They also improve the comfort and durability of our buildings and the health and safety of the occupants. In addition, the federal government has mandated that Georgia must reach 90% compliance with the current adopted energy code by 2017. In this video, we will introduce you to Georgia's Residential Energy Code Field Guide and walk you through many of the important elements of the Field Guide so that you can improve Georgia's energy code compliance in homes. Thank you for helping Georgia build to the energy code.
When inspecting residential construction, the Field Guide can be used as a checklist to make sure you have properly covered the required items for compliance with the energy code. To use the Field Guide properly, you must understand how to determine where the building thermal envelope is located for a given home. The building thermal envelope represents the boundary that separates conditioned space from unconditioned space. It should consist of a thermal barrier like insulation and a pressure barrier like drywall, OSB, or plywood that are both in continuous contact. In a home, the building thermal envelope typically includes the exterior walls, windows, doors, ceiling, attic knee walls, and floors. As we discuss the requirements of the Energy Code, we want to keep in mind that any insulation, window, and air sealing requirements in the Energy Code only pertain to the portions of the building that make up the actual building thermal envelope. For example, an exterior wall or a wall separating a conditioned room from the garage would require insulation and air sealing. However, walls that separate the garage from the exterior or a wall that separates interior rooms from one another do not need to meet Energy Code since they are not part of the building thermal envelope. When inspecting a home for Energy Code compliance, you must conduct several inspections in a home. The Field Guide and this video will walk you through many of the items in the Energy Code in the order of the inspections that must be performed. The first inspection is a pre-insulation or framing inspection. At this inspection, check for the mandatory air sealing requirements in the code. At the rough-in inspection, ensure that air sealing has been performed underneath and behind tubs by installing an air barrier behind the tub and sealing holes underneath tubs. Sealing wire penetrations in the top plate is another mandatory requirement in the Energy Code. You should make sure all chases are capped and sealed. Chases can serve as very large holes in the building thermal envelope. Finally, joists should be blocked between conditioned and unconditioned spaces in garages. This is important not only to save energy in a home, but to make sure pollutants like carbon monoxide do not get into the home. At framing, you can also inspect for the window requirements in the Energy Code. It is important to verify that fenestration, windows, and doors meet the requirements of the Energy Code, such as air leakage, U-factor, and solar heat gain coefficient, or SHGC. Window and door U-factor specifies how much insulation the fenestration provides. The lower the U-factor means the door or window is a better insulator. SHGC defines how much heat incident on the window gets into the home. Having a low SHGC for windows is critical in the Southeast to reduce the amount of radiant energy gained by the home during the summer. Because of the performance specifications for U-factor and SHGC, a double-pane low E window is effectively required by the Georgia Energy Code. When using the prescriptive path, every home gets a 15 square foot exemption for windows. A builder could use this exemption to install glass blocks or decorative transom windows. In order for windows in the state to meet Energy Code requirements, they must have an NFRC label. Otherwise, the window is assigned code default values for U-factor and SHGC, neither of which would pass code. A second building inspection occurs once insulation is installed in the building. Because even small gaps in insulation can reduce effectiveness by more than 25%, the Energy Code stipulates that the wall insulation must be installed according to manufacturer's instructions. Therefore, inspect walls to make sure that batts are cut to fit and that they are split to fit around electrical wires and cables. Also make sure the batts are not compressed. The Georgia Energy Code states that underfloor insulation must be installed so it maintains permanent continuous contact with the underside of the subfloor decking. Insulation that does not touch the subfloor decking does very little to prevent heat transfer from the home. When installing underfloor insulation, utilize wire staves or tiger teeth to support the insulation. An attic knee wall is any vertical wall that has conditioned space on one side and unconditioned attic space on the other. Insulating the attic knee wall is especially important as there is a large temperature difference across the knee wall, particularly in the summer. For specific information on how to insulate the attic knee wall, refer to the Georgia Field Guide. You can inspect for the remaining items in the Field Guide at the third and final inspection. Installing proper ceiling insulation is another important criteria in the Energy Code. In the prescriptive Georgia Energy Code, R30 is required throughout the entire attic. R38 is required in Climate Zone 4. If loose fill insulation is used, one attic ruler must be provided every 300 square feet to confirm consistent depth. If a builder uses less ceiling insulation, for example if they sprayed foam along the roof line at R19, then ResCheck software can be used to perform a simple trade-off within the envelope. These are just a few of the insulation requirements in the code. See the Georgia Residential Field Guide for more information. At the third and final inspection, you can also make sure that the remaining mandatory air sealing requirements are met. The code requires that builders use airtight IC-rated light fixtures whenever the fixture is located in an insulated ceiling. Unlike standard recessed lighting fixtures, these airtight fixtures do not create holes in the building thermal envelope. The Georgia Energy Code also requires an air barrier on the attic side of the knee wall. You should inspect for blocking between the floor joists underneath the attic knee wall. Air sealing the access to the attic is another mandatory requirement in the Energy Code. You should also check to make sure the insulation requirements are met. R5 is required for attic knee wall doors and pull-down stairs, and R19 is required for scuttle holes or hatches. Sealing penetrations from duct boots and electrical boxes, as well as light fixtures and other penetrations, is another key requirement in the Energy Code. For illustrations of these air sealing measures, please see the Georgia Field Guide. The code also requires that all ducts in Georgia be sealed with mastic that is at least 2 millimeters thick or approximately the thickness of a nickel-on edge. While silver UL 181 tape may be used to assemble ducts, mastic is required as a primary sealant. If any ducts or air handlers are located outside of the building thermal envelope, then the code requires that the system be tested. The Energy Code requires that a certified duct and envelope tightness, or DET verifier, confirm that the ductwork is tight enough to pass Energy Code. Total duct leakage at rough end must be less than or equal to 6%, while total duct leakage at final must be less than or equal to 12%. Post-construction leakage to outside testing occurs at final and must be less than or equal to 8%. These percentages are based on the CFM25 of duct leakage divided by the floor area served by that duct system. Once the result is determined, the certified DET verifier must record the results on the Energy Code compliance certificate. Another provision in the Georgia Energy Code is the mandatory requirement that a certified DET verifier test the building thermal envelope with a blower door. Standard practice is to depressurize the home to -50 pascals and then measure the CFM50. The CFM50 is used to calculate the ACH50. The Energy Code requires that a home test out less than 7 ACH50. Once the ACH50 is determined, it must be recorded on the Energy Code compliance certificate, which must be located on the electrical panel box or air handler. It should include the manual J-load calculations, another important requirement of the Energy Code, as well as the major insulation characteristics of the home. The Energy Code also requires that homes have efficient lighting. At least half of all the bulbs in the permanent fixtures in the home must be efficient or be controlled with an occupancy or vacancy sensor. Bulbs that meet the efficacy requirements include compact fluorescence, T8 or T5 linear fluorescence, or highly efficient bulbs that meet certain lumen per watt requirements, like most LEDs. Fat T12 bulbs do not meet code. This video details the main requirements in the Energy Code, but not all. For more details, visit Southface's website to download the Georgia Field Guide, watch a video on how to conduct a blower door and duct blaster test, or attend a training.